kg is lying on a rough inclined plane of inclination 30 degree. Find the magnitude of force parallel to the incline needed to make the body move up the incline, and second is down the incline. Okay, coefficient of static friction is given. So first we make the diagram. So this is the incline and a body is kept here, and what are the different forces acting? First we will see, and then we will apply the external force. So one is mg, second is normal, third is, since it will try to slide down, so friction will act up in normal situation without applying any external force. Okay, so if you want to move it up and if you want to move it down, in these two cases the friction will act in opposite direction. If you want to move it up the incline, then since it is trying to move up, the friction will act down. Okay, so in this case you can see how the friction is adjusting itself. Since you are applying an external force to move it upward, this is the external force F0, the friction will act down. Okay, so friction will act in this direction. So this is case A. And for B, if you see, the friction will be just opposite. Means the object is here, mg is fine, normal is there. Okay, and since we have to move the object down the incline, the friction has to act up. In second case, friction will act up, and in first case, friction will act down. Okay, so we have to find this external force needed. So how do we write it? So if we write the equation, this is x and this is y. So equation along y, that is mg cos theta equal to normal. So this is the value of normal. I am directly writing it. Equation along x. Equation along x, it will be how much? Since it has to go up, the upward force must overcome these downward forces. So downward force will be how much? This angle is theta. So downward forces must be F and mg sin theta. So F0 upward must balance the friction force downward plus mg sin theta. Okay, and friction force is mu times normal plus mg sin theta, and mu times normal is mu mg cos theta plus mg sin theta. So this is the value of friction force as applied force, value of external applied force. We can find this numerical value also. So mu is how much? Mu is 0.2, m is 2, g is 10, cos theta, cos 30 is √3/2, m is 2, g is 10, sin 30 is half. Okay, so we are going to get 5√3, sorry, not 5, 5√3, 2√3, 2√3 plus 10. So this much is the external applied force. This much we are going to, this many newtons for moving up the incline. Okay, similarly, if you write for moving down, so for second case, if you see, this is the first case. If you see the second case, in second case, one thing may happen that mg, if mg sin theta is greater than friction, the object may slide without applying any force. That could also happen. So that we need to check. So if we write the equation, the normal will be equal to mg cos theta. Okay, in second case, it will be F0 downward minus friction, F0 downward plus mg sin theta downward will be equal to friction. Okay, F0 is coming how much? Friction minus mg sin theta. But in this case, you can see friction minus mg sin theta. You can have mg sin theta greater than friction. In that case, you need not to apply any external force. It will slide by itself. So friction is mu mg cos theta minus mg sin theta. So this is the answer in the form of expression. But if you put the numerical value, we have already calculated this value. See, mu mg cos theta, that we have already calculated. That is 2 root 3, and mg sin theta is 10. So you can see this is negative. What does it mean? If you are getting negative, means mg sin theta is larger in magnitude. So the object will slide by itself. You need not to apply any force. Actually, negative means what? The force is what? Whatever force we were thinking that we have to apply to balance all this maximum friction, we have to apply opposite force. So actually, if you want to move it down, no need to apply force. So since it is negative, object slides by itself. Object slides by itself. Slides by itself. Why? Because mg sin theta is greater. Because mg sin theta is greater than mu mg cos theta. No need to apply any force. No need to apply any force. Okay, so in this way we can do.